Now let us see the working of ultrasonic sensor with Raspberry Pi. For this, we require jumper cables, ultrasonic sensor, breadboard and a Raspberry Pi. The ultrasonic sensor consists of 4 pins. The VCC pin for power supply, the trigger pin, the echo pin and the ground pin for connection of ground. The trigger pin emits the radiations and the echo pin receives the reflected back radiations. Now let us make the connections. Here we have connected the black wire to the ground of ultrasonic sensor, the blue wire to the echo pin and orange wire to the trigger pin and red wire to the VCC pin of ultrasonic sensor. Now let us connect these wires to Raspberry Pi. Here we are going to connect the black wire to the pin number 6, that is ground pin of Raspberry Pi, the VCC pin of ultrasonic sensor to the pin 2, that is 5 volts power supply of Raspberry Pi, and the trigger pin we are going to connect it to the pin number 12 of Raspberry Pi. And the echo pin we are going to connect it to the pin number 18. Our connections are done. Now let us run the code.
Now, let us see the code to work with ultrasonic sensor. First, we import the rpi.gpio and the time libraries for fetching the required functionalities of Raspberry Pi and for working with time. The GPIO pins are set to 18 as the output pin and 24 as the input pin. The trigger pin is the one that gives out the signal which are caught by the echo pin. Initially, the trigger pin is set to high to enable the emission of the signals, and then this emission is stopped for 0.01 millisecond. The start time and the stop time variables are created in order to store the time variables. Just before the echo pin does not receive the signals, the start time is measured, and when the echo pin suddenly receives the signals, when the trigger pin is set to high, after colliding with an object, the stop time is measured. This time difference between the stop and the start time is calculated, which is then multiplied by the speed of light. Division by 2 takes place here as the signal has travelled from the trigger pin to an object and has again come back from object to the echo pin. So, we need to find only the half of this distance, and this distance is returned as the output. During this process, if keyboard interrupt like Ctrl and C is pressed, then the operation stops. Now, let us run this code. Here we can observe that as an object comes near the sensor, the value of the distance measured goes down, and again as the object is taken far away from the sensor, the distance measured is increased.